Okay, good morning, everyone. How did the homework go? All right, any other questions beside number 58, which we will definitely do? Any other questions? 58 and 34, okay. Um, right. So we are going to start by 34 and then we do number 58. And if anybody has any other questions, please feel comfortable. So the two formulas that I want you to know, which are simple: volume of a disk, which is pi times the radius square times the height, which will be the area of the base times the height. And the other thing is volume of a washer, the one that we saw yesterday, which is pi times the height. The height usually is the delta y or the delta x. And this is the outer radius square minus the inner radius square. And this is area of the base of the washer. And this is the height of the washer. So these are the only two formula that I will require you to learn from this section. Everything else we'll figure it out as we did yesterday. So I start with number 34. I have to read it. Right. So the question is, so number 34. Okay. So we have the graph of y equal the square root of sine x, y equal 1, x equal to 0. So that's the region, that's my region R. And we're gonna rotate about the x-axis. And the question is, find the volume of revolution. Find the volume of the solid. So as usual, step one always is we have to know what region we are working with, and then we start revolving and finding everything we need. So let me graph first. Okay, so let me graph it. Y equal the square root of sine x. So this between 0 and pi, we know that the sign is positive between 0 and pi. So that's the graph of sine. The graph of the square root of sine is going to be kind of similar. At 0, I am at 0. At pi, it's also square root of sine pi is 0. And at pi over 2, so it's going to be a little bit very similar. Sine pi over 2 is 1. The square root is 1. So this is going to be 1. So it's going to be very similar to this graph, kind of. Not the same value, but it's very similar in shape. And y equal to 1. So this is the point. This is pi over 2 and 1. Y equal to 1 is going to be, this is y equal to 1. And x equal to 0, x equal to 0. So this is 1. And this is the region I'm interested in. And we're going to rotate this about the y-axis. So we're going to get something like that. So that's really the solid we're going to get. So it's basically like a cylinder if you want, and you're taking away from it this little ball inside. That's really the picture. And the question is, what's the volume of the solid? Okay, we're going to proceed as we did yesterday. The idea is we're going to fill this up with those little tiny rectangle We're going to rotate each one of them, which is going to generate a washer, find the volume of a typical washer, and then add all those volumes. So we are basically, in your mind, this solid is going to be filled with those vertical washers, and we're adding their volume. All right, so now let us get to work. So this is the picture here. Right here, I'm going to draw the picture again, because here I use that one to, so this is y equal the square root of sine x. Right here, it's the pi over 2. This is a 0, and that's really my region. So this is my axis of rotation, which play an important role, is the x-axis. So now I'm going to take very typical piece right here. So that's really my little piece that I'm going to rotate. And when I rotate it, I'm getting the washer over here. So from down, I'm going to go down, and I'm going to label this xi. Okay, you can label it x if you want. For xi, I will accept both labels. So now when I rotate this piece, we know that we are going to get a washer because we have a big hole in here. And our job is basically to find the volume of the washer. So I will focus on a typical washer. To find the volume of a washer, as I said, we need to find inner, outer, and height. Once we do those, the problem is actually almost done. So I put my parentheses right here, the outer, the inner, the height, every aspect of it, and then the volume. Okay, every piece of it. The height is the one that make it a volume. So the height is from here to here. That's my delta x because I am dividing the interval on the x-axis. And now the inner. What's the inner in this situation? If I call this xi, it means from here to here, this is my xi. And my inner is going to go, so that's, we're rotating this. So my inner is going to go from their axis of rotation, which is lives here, all the way to the inside curve. Okay, draw the picture. Do not memorize anything. So that's my inner here. So if this is xi, from here to here, I have the y value, which is the square root of sine xi. So my inner is the square root of sine of xi. What's my outer quickly? What is my outer? 1, of course. It's from the axis of rotation to the outer curve. So my outer is, let me use red for it. My outer is going to be from the axis of rotation to the curve, which is the farthest away from the axis of rotation. This is going to be my 1. So the volume of the washer is going to be the area of the base. It means the base, it means because the washer is like this. That's really the washer we're talking about. That's the base. So you're taking the area of this base, you're multiplying by this little bit of a height. So we have volume. So we'll be adding volumes, not areas. So it's pi times the little delta x, which is making it into a volume. And here, the outer square, that's the outer square, minus the inner square, I square. So that's the volume of a washer. Once you are at this stage, believe me, you are absolutely done with the problem. Almost. Now the setup. So the volume is almost the sum of the volume of those little washers. So we're filling this with those vertical washer, and we're adding their volume. So this is my delta x, and this is 1 minus the square root of those square. I equal 1 to n. So this is my Riemann sum. So finally, the volume is the integral, domain of the integrals. I always go back to my picture. To cover this whole region, with those little rectangle, I need to divide the interval from 0 to pi over 2. These are my bound. 0 to pi over 2 of pi times 1 square. As you realize, I keep writing the square root of that just to always remind you it's the outer square minus the inner square dx. Now we simplify and we start evaluating. Pi is a constant. Inside, I will have 1 minus sine x dx. So this is equal to pi times. And now we evaluate the simple integral. Antiderivative of 1 is x. Antiderivative of sine is minus cosine between 0 and pi over 2. So it's equal to pi times upper minus lower. At the upper, I will have pi over 2 plus cosine pi over 2 is a 0. At the lower, I have 0 plus cosine 0 is 1. So finally, I will have pi times pi over 2 minus 1. And I know it's a positive number because pi is 3.14 divided by 2 is more than 1. So this is definitely positive. So always look at the answer. If you see something negative, it means, of course, we're doing something wrong. Any questions before I move on to number 58?
Professor Elias,
Yes.
I had a question about how did you know the domain was between 0 to pi over 2? Because it didn't say it in the textbook, and I went from 0 to pi.
Oh, okay. All right. I did it intuitively, but now I will explain it. Are you with me? Okay. This is y equal to 1, and that's y equals sine. What you need is the intersection between y equal 1 and the graph of the function. Are you with me with that?
Yes, that makes sense.
So how do you do that? You said, so let me solve. Let me find the intersection point, not intuitive. Let me find them correctly. Algebraically. Intersection. Okay. How do we find the intersection? I have to set the square root of sine x equal to 1 and solve. I stop for a second to make sure you understand.
Yes, I understand.
And everybody else. That's how I got to pi over 2. It's a good question. Now I need to solve this, so I have to square both sides. It means sine x equal to 1. And then what is x? What's the angle whose sine is 1? The angle whose sine is 1 is pi over 2. So when I took the curve y equals sine x and the line y equal to 1, I cannot proceed till I find the intersection. So the intersection occur at pi over 2. It means this point here has to be pi over 2. Good question.
If
Anybody?
there's like any, yeah, sorry, if there's any confusion, like on the quiz or test, is it okay if I ask like, oh, what domain did you want this in? Or do you want us to intuitively?
No. I want you to be able to sketch the graph, and usually I'm giving you, usually the way I approach it on the exam is, if it's easy curve, I let you graph it, like square root of x, x square minus 1. If the graph is hard, I usually give you the graph. However, I expect you to be able to find the intersection point.
Oh, so it's usually between whatever the X is given to the intersection point.
Yes.
That's like what we're
Yes, you
doing.
have
Okay.
to,
That
exactly.
make
You have to find the intersection point. I will not give you those.
okay, gotcha. Thank you.
Yeah, absolutely. Any other questions concerning this problem? I saw your question, a problem number 49. I will look at it also. Okay. So let's move on. Please ask questions. It's important to not only understand the material, understand graphs, which is, I think, very important for us. So I look at 49 before I proceed to the last problem, which is 58. So 49, okay. So this time they give us y equal 1 minus the square root of x, y equal 1, x equal 1. That's the region, and I actually graph the region. And rotate about, so the axis of rotation is rotate about y equal 1. Okay, so obviously I don't know anything without really graphing. And in this problem, the book gave you the graph. They don't have to, but they actually gave it to you. So this is the graph. Y equal 1 minus root x. Basically, it's the root x flipped, then shifted up. That's the way you would have graphed it if you don't have the graph. You start with the square root, you reflect it across the x-axis, and then you shift it by 1. So that's how the graph is going to look like. So that's the graph. And then x equal to 1, that's 1. And y equal to 1 is this. So in this particular problem, the book basically gave you everything. All right, so this is the piece we have. And the axis of rotation is y equal to 1. That's my axis of rotation. Okay, so where I'm rotating now, I'm rotating like this. That's the picture that I have in mind. Okay? And the question is, we need to find the volume of this little thing, of the solids that you guys see. The process is verbatim the same. So this is my 0, 1. And I'm going to take a piece here, my little piece. So, but when I take a piece, I have to label. So for my mind, this is my xi. Without labeling, you are confused. And it's this piece I'm going to rotate around the line y equal to 1. So question number 1, when you rotate about the line y equal to 1, what are you going to get? A disk or a washer? I ask my question again. When you rotate this around the line y equal to 1, do you get a disk or a washer?
A disk.
Absolutely a disk, because this rectangle is touching the axis of rotation. So no, it's not a washer. We are getting a disk. It's touching the axis of rotation. So when you rotate it, you're actually going to get a disk, not a washer. So rotate a slice. So we have to be very clear about that. Rotate a slice, which is a vertical slice. This would give me a disk. All right, so first of all, you have to ask yourself, what do you get? Question number 2 is, so that's okay, Jonah. Question number 2 is, what's the volume of a disk? So the volume of a disk is pi times the radius squared times the height. So now we need typical disk. Typical disk, okay? For a typical disk, I need the radius, there is no more outer inner, because it's a disk, there is no hole inside. I need the height, and finally the volume. Okay, the height is this delta x from here to here. That's my height. And now, what is the radius? I want answers to the radius. I want you to look at the picture. As I said, no memory, look at the picture. The radius is from here to here. That's the radius. Who can give me the formula for a typical radius?
It's 1 minus root x.
So it's 1 minus 1 minus the square root of xi. Is your classmate correct? Is your classmate correct?
Yes.
Every one of you should be able to do it when I'm asking the question. That's how you're going to learn the material. It's 100% correct. Because what's the radius? It's the value here minus the value here. The upper minus the lower. But this here, this point is on the graph down here. So if this is xi, this vertical distance, this vertical distance is the value of the function at xi. So the upper minus the lower, 100% correct. That's the radius. At this stage, believe me, the problem is done. The volume is the area of the base. It means pi times the radius square, which is 1 minus that, times the height. The area of base times the height. So that's my disk. The volume of it is the area of the base times the little height to make it into a volume. Actually, otherwise it will not be a volume. So now let us find the volume of the solid. It's equal to the following integral. The bound. The bound are important in math, very important in setting up problems. I go again to my curve, and this is everything was given to you, so you really didn't have to do much. I have to integrate from 0 to 1, and then the inside. So it's pi times the radius square. I will simplify in a second. I'm rewriting it like this to tell you that's the radius times dx. So now we're almost done at this stage. So that's the integral from 0 to 1. The pi, I take it out. 1 minus 1, it is 0. So I will have the square root of x squared dx. It means equal to pi integral from 0 to 1 of x dx. It means pi times a half x squared between 0 and 1. It means pi over 2. End of the problem. Okay. Questions?
I have a question.
Yes.
If you would rotate it by the zero axis, would anything change? Would the bottom function be the top curve then? I was just wondering about that.
I have to make your question very clear, Rocco. So, okay. All right. What do you want to be the axis of rotation?
So if the x-axis instead was the axis of rotation, would anything be different?
Yeah, first, when you take a piece here and you rotate it, what are you going to get around the x-axis? A disc or a washer? Question number 1.
This time would be a washer?
Absolutely. So the whole problem will be different.
Okay, I see. Okay,
Totally
so I
different.
did, because
Go
I did
ahead.
the problem wrong. I assumed it was a washer, but now that I'm seeing it's a disc. Okay, I
Yes.
see. That makes sense.
Here it's a disc because we're touching the axis of rotation. This is absolutely a washer. Very different problem, very different everything. Understand? I mean,
Yeah, I understand now. Okay, that makes sense.
the inner is going to be the square root of xi. The outer is going to be 1. And the setup is going to be the integral from 0 to 1 of pi times the outer square minus the inner square. If you rotate around the x-axis.
That's the area I got when I was doing it last night. Okay, that makes
Yes,
sense.
you
Okay.
have it. Okay. All right. So we move on to number 58, and then we move forward. So number 58, I will not compute the integral, but we will set it up at least, and we set it up together. As I said, please, every one of you, try to answer the questions as we're doing them. So here I have the following region. So y equal to x, y equal 1 plus x over 2, and about, so we are rotating about y equal to 3. Okay, so let's do that. I'm gonna graph as usual. Okay, y equal x, we know what y equal x is. That's y equal x. Y equal 1 plus x over 2. So that's a straight line. It's 1 here. If x is 0, y is 1. x over 2, the slope is a half. So it's sloping a little bit less than this one. So that's really my line. And they intersect somewhere. So that's the region in question. And y equal to 3. So before I draw y equal to 3, I'm going to find the intersection point so I know what I am working with. So let us find the intersection point. Otherwise, I don't know what to do in this problem. Intersection. Okay, so we set them equal. So I'll have x equal 1 plus x over 2. So this is going to give me x over 2 is 1. So I bring this here. It means x equal to 2. So this point to right here is 2. And what's the y coordinate? So that's a 2, of course. And if I put 2 here, that's 2 and a 2. So now I know exactly my region. And I'm going to rotate around y equal to 3. Y equal to 3 is going to be somewhere right here. So I'm going to draw it again because this is not. So draw again. So I have this line and that line. So that's the point 2, 2. And this is 1. This is 2. So 3 should be here. That's y equal to 3. It's my axis of rotation. Okay, and so this is the axis of rotation. I stop. Is everybody with me so far? Okay, so we're gonna get like a weird figure. We're gonna get something like that. You know, that's the type of picture we have. So, but we don't worry about that. Now what we have to do is, so this is my 2, so that's the region. And the way we're going to cover it is, we're gonna take a slice within the region. Of course, that's where my slice is. I'm gonna call this is xi. And remember, I'm rotating about the line y equal to 3. So I'm rotating this way and that way. That's really what I'm going to rotate. So question number 1. We're going to rotate a slice. And this is a vertical slice. And what are we going to get? Desk or washer? I always ask those questions. Quickly. Desk or washer?
Washer.
Washer. Because this is not touching the axis of rotation. So when I'm going to rotate, I'm going to have a big hole right there. Question number 1. Question number 2, even though it's not very relevant here, but it's going to be relevant in a second. My variable is x. X is the variable. Because I'm cutting the interval along the x-axis into pieces. Now, we need a typical washer, so we need definitely to find the inner and the outer radius, and then we will be practically done once we can figure out all those. So typical washer. Since it's a washer, I need the inner, I need the outer, I need the height, and finally the volume. The height in this case is the little delta x. It's the inner and the outer that I am interested in. Okay, let us start with the inner. What's going to be the inner radius? I'm not going to draw anything. I want your answer, and then I draw. What's
1
going to
plus
be
x
the
over
inner
2.
radius? What?
1 plus x over 2.
Okay, your classmate is telling me 1 plus x over 2. True or false?
It would actually be 2 minus x over 2 because you have to 3 subtracted by the
I want the second one. So, okay, 1 plus x over 2 is wrong. Why it is wrong? What is the axis of rotation?
Well, then you'd have to subtract 3 from
Right,
it.
y
So,
equal to 3. So the inner is going to be where? If this is xi, the inner is going to be, so you go up here. From the axis of rotation till this curve right here, that's going to be the inner. Because if you rotate it in your mind a little bit, that's going to be the whole. So the inner is axis of rotation all the way to this curve right there. So please mute yourself. So what's going to be the inner? 3 minus. This point is on the curve 1 plus x over 2 minus 1 plus xi over 2. So that's going to be my inner. So my inner is, So my inner is 3, the upper value, minus this value here, 1 plus xi over 2, which is we're going to simplify, as your classmate said, it's 2 minus a half xi. Now, what is the outer? I will not draw it. All of you figure it out yourself before we get. Even if you don't answer, make sure you know it in your head. What is the outer? I'm listening and I'm writing. 3 minus x, Aaron tells me. Do you agree with Aaron? You agree with him? Anybody? Okay, I do. So, what is the outer? That's the axis of rotation right there. It's from the axis of rotation all the way to here. The outer is from here to here. The axis of rotation to the lower curve, because that's the farthest away from the axis of rotation. That's going to give me the outer radius. So the outer radius is going to be the upper value 3 minus the xi. So the outer radius is right here, 3 minus xi. So my volume would be pi times area of the base, which is the outer radius square minus the inner radius square times the height. So finally, the volume of the solid is going to be the integral. The bound, let me go back to the bound. The bound are going to be, we already found the intersection point. It means that's the interval I have to divide into pieces to cover this with those rectangle and rotate every one of them. So it's going to be integral from 0 to 2 of pi times area of the base times the delta x. That's the volume. And this will give me 3 minus x squared minus 2 minus a half x squared. I will not evaluate. And the only way you will evaluate this, you need to distribute this term. That's the only way you can do that. And then the rest will be just a simple integral. Okay. Please go over those problems by yourself again so you can fully understand how we think about them, how we understand a graph. What is the output? What's the input? Okay, today we are going to do the same thing, basically, but we're going to rotate around the y-axis instead of the x-axis. So, rotation about the y-axis. And the principle is the same. Instead, the only difference that instead of covering the solid with those vertical washers, we're going to cover it with horizontal washers. So it's the same approach, but y will be our variable. So rotation about the y-axis. So I'm going to do that using examples. There is no need for formula. The only formula you need is volume of a washer, volume of a disk. That's about it. So, question. Find the volume of the solid obtained by rotating or revolving, by rotating the region bounded by the following, the graph of y equal x cubed, y equal 4x, by rotating the region in quadrant 1. In the first quadrant, bounded by y about the y-axis. Okay, so step number 1, which is always step number 1, is to graph, and then we proceed. So graphing. Okay. So that's example of a typical region I will give you without giving you the graph. So I expect you to know those type of region. Why? And I want it only in first quadrant, so I'm making our life easy. So this is y equal x cubed. It usually goes on like this, but I'm only interested in the first quadrant. Y equal 4x is a straight line. Okay. As you know by now, we always need the intersection point. And when we find the intersection point, either we set the y is equal or the x is equal, depend which one we think it's easier. In this case, setting the y equal is very easy. So intersection before I proceed. So intersection. Okay, so I will set x cubed equal 4x. Okay, and remember, you don't simplify by x. The only way to do it, you set equal to 0. Otherwise, you will be losing solution. We don't want to do that. I factor out my x. I will get x squared minus 4 equal to 0. I solve x equal to 0. And this will give me x equal plus or minus 2. Now, of course, I'm not interested in the minus 2, so I only want the positive solution. So this gives me that this is 2. That's the intersection. And now whether I plug 2 in this formula or this formula, I'm going to get the same. I will get 8. So now I have a good understanding of the region. So that's my region. But now that's the different thing here. I'm rotating it about the y-axis. Okay, instead of the x-axis like before. So what type of slices I'm going to take? So this is my 8 here, right here. So in this problem, I'm gonna take those horizontal slices. Okay, so this is the rotation here. And this is the piece that I usually try a little bit to visualize the picture. I'm rotating this way. That's the rotation. And I'm gonna take this piece here. So I'm gonna cover this region with those washers. So when I'm rotating that, I'm gonna get something like this. So that's the washer that I'm gonna cover the other region with. Okay, and this whole region will be covered washer on the top of the washer, on the top of the washer, on the top of the washer. And of course, the outer and the inner is going to change. So the principle is the same. When I take this one, this slice, and I rotate, so this is, I'm gonna call it my yi. It means my y is going from here to here. That's the y in my head. And when I'm gonna rotate this, so this is gonna rotate it like that, and this is gonna rotate it like this. And then this is the washer I am after. So now I need to find the volume of this washer. So a typical washer. So rotate this time. I'm gonna rotate horizontal slice. Give me a washer. Okay. And in this problem, before we start finding the inner and the outer, what's going to be my variable, x or y, quickly? What's going to be the variable? It means we look at the interval. I look exactly, the variable y is the variable. So everything, and I mean everything, has to be expressed in terms of y. No more x's. All right. Now, typical washer. It means I want the inner, the outer, the height, and finally the volume. Right. Now I'm going to be quiet a little bit. I want you to look at the problem and tell me how are we going to find the inner radius. So I'll let you think about it and then I'll explain it. So give you 30 seconds to tell me what's the inner radius, how are we going to find it. Please, when I'm asking a question, I want all of you to think about it. Draw it in your mind, the inners from where to where, and what do we need to find it. Anyone? Solve, exactly. We have to solve. So let us repeat. Y is my variable. It means in this scenario, I know the Y and I want the inner. So the inner radius is going to go from the axis of rotation to this curve right here. That's the inner. So it means I know the Y. What I want now is the horizontal distance from the Y axis all the way to this point. To be able to find a horizontal distance, it means I need the X in terms of Y. I know the Y, I need the X. So let us go after that, and that's crucial here. This curve is Y equal for X. It means X is 1 over 4Y. And let's do it for both of them at once. This is Y equal X cubed. It means X is the cubic root of Y. I am after horizontal distance. I need the X that correspond to Y. Now, with this in mind, if this is YI from here to here, this is a point on the curve. This point here is the X. So this is 1 over 4 YI. So my inner is going to be 1 over 4 YI. So my inner, 1 over 4 YI. Y is the variable, everything in terms of Y. Now my outer is like before. From the axis of rotation, all the way to the curve which is the farthest away. This horizontal distance from here to here, this is my outer radius. So my outer radius is going to be, this is YI. I need the X that correspond to it. So if I know the Y, the X is the cubic root of YI. So this is going to be the cubic root of YI. So my outer radius here is going to be the cubic root of YI. My height is from here to here. That's what's going to make it into a volume. Otherwise, I will not be adding volumes. That's the delta Y. So the volume of a typical washer is going to be pi times. This is the delta Y. And this is the area of the base, which is pi times the outer radius square minus the inner radius square. Outer square minus the inner square. So that's area of the base times the height. Now I set up my integral. So where is my integral? So what is the volume? It's the integral. Right. What are the limit of integration? What are the limit of integration? 0 to 8, absolutely correct. You ask yourself, which interval I need to cut into pieces to cover this region with those horizontal rectangles? It's from 0 all the way to 8. So we are working with the y-axis. So from 0 all the way to 8. These are my limits. And then the volume. It's pi times dy, that's the little height, and this is the area of the base squared, that's the outer, minus the inner square. That's the setup. So now let us see if we want to evaluate this, what do I get? So this is equal to. So that's equal to the integral from 0 to 8, pi is a constant, I take it out, dy. The cubic root of y, that's y to the power. The root is the 3, the power is 2, y to the power 2/3 minus 1 over 4y squared is 1 over 16 times y squared. And the rest is simple math, or simple integration, I would say. So pi times from 0 to 8. Antiderivative of that is 1 over 2/3 plus 1, which is 4/3. Y to the power 4/3 minus 1 over 16 times 3, 48, y to the power 3. And finally, I get pi times at the upper minus the lower. The lower in this case happened to be 0. The upper is 3/4, 8 to the power 4/3 minus 1 over 48, 8 to the power 3. And the rest, you guys evaluate. I'm not going to evaluate. Questions? Okay, so it's the same thing, but y is the variable. All right, I will do one more problem along those lines. And I'm going to rotate about a line which is parallel to the y-axis. So example number 2. Power of 5/3. Did I do something stupid? What is it here? 2/3 plus 1, 5/3. Thank you very much. My apology. 5/3, 5/3, 3/5. Thank you. All right, any other issue? Okay. So now I'm going to take the same region as in this example, and I'm going to change the axis of rotation. So this is my question. This is my problem. So example number 2. Okay, R is the region as in the previous problem. So R is the region in quadrant 1, bounded by y equal x cubed, y equal 4x. So the same region. But now we're going to rotate about, let's see what I want, x equal -1. Find the volume of the resulting solid. All right, let's do that. So I go back to the graph, which is we've already done it. We did everything for the graph. So this is my picture here. And y equal x cubed was this one here. And that's the line. This and the intersection was to 8. So we know all the ingredient. This was y equal x cubed. And that's what we had from previous. And this one is y equal 4x. X is 1 over 4y. Okay. But now I'm rotating about the line x equal -1. So as we did yesterday, we're just shifting the rotation. So x equal -1, and this is my axis of rotation. That's what I'm rotating over. So again, I'm going to cover this region. I'm taking slices which are parallel to the axis of rotation. So these are the little pieces I'm rotating right there. And this is here my yi. And I'm rotating that piece. Okay. So now rotate horizontal slice. And if I rotate a horizontal slice immediately, what do I get? A washer or a disc? Because it's important. Of course, we're gonna rotate. There is a huge hole here. There is nothing here. So this is gonna give me a washer. And since I'm taking horizontal slices, it means y is the variable. So now we're going to do exactly what we did before. We're going to take a typical washer. And I want everything. I want the inner. I want the outer. I want the height and the value. And then the rest would be simple. Okay, now I go back to you. What do you think is going to be the inner radius? I'll give you a minute to think about it and then I'll explain it. Okay, I'm having somebody, one of your classmates is telling me it's 1 over 4 yi minus 1. Is your classmate correct? Yes or no? Anybody? Okay, Aaron is
Yes.
telling me, let us think about that. So first we draw it. This is my yi. This is my axis of rotation, crucial. So my inner is going to be from here all the way to here. First you draw it before you do anything. So this is going to be my inner. From your axis of rotation, this is your yi, your axis of rotation till you hit the curve. That's going to be the inner. What's the horizontal distance from here to here? The horizontal distance is always your right value minus your left value. Your right minus your left. But what is the right value here? If this is yi, this is point on the curve y equal 4x, it means your right value is 1 over 4 yi. The left value is minus 1. So the radius is going to be right minus the left. So it means 1 over 4 yi minus 1. It means 1 over 4 yi if you want plus 1. So that's the correct value. It's the right minus the left. Be very, very careful. Okay. Now what is the, so the inner, we have it. It's the right value minus the left value, which is 1 over 4y plus 1. Or basically, you can look at it. From here to here is 1 over 4y. You're adding 1 to it. That's another way you can think about it. So we're making the inner radius definitely bigger than the inner radius when we rotate about only the y-axis. So we're adding 1 to the inner radius. Now the outer radius. Again, so this is from the axis of rotation all the way to here. That's my outer radius. And it's the same thing. It's the right value. But if this is yi, this point on the curve, it means this is the cubic root of yi minus the left value. Or it is from here to here, cubic root of yi, you're adding 1 to it. You can think about it in 2 ways in this scenario. So this is going to be, the outer is going to be the cubic root minus 1, or the cubic root plus 1. Height is the delta y, and the volume is times delta y. The outer, cubic root of y plus 1 square minus the inner, 1 over 4y plus 1 square. So finally, the volume, I set up the volume and we stop. It's integral from 0 to 8 of pi times cubic root of y plus 1 square. That's basically my outer square. I take away from it my inner square. To integrate, you definitely distribute. It will be a little bit long, but not hard. End of the problem. Okay. So I stop right here today, of course, and I will assign problem along the same line. Please make sure to do them. Sketch, graph, and understand everything geometrically. Do not memorize anything at all except the basic volume of washer, volume of a disk. Right? Any questions before I let you go? Okay, remember I have office hours right now. Please join me if you have anything. Please join me if you have any questions.
Hello, Professor Elias.
Okay, bye-bye, guys. Thanks.